Lines part 2. Let's go. All right, we'll start with review. What we're going to be doing in this lesson is we're figuring out the missing angle measures. So now we're looking for the degree measures, the angles that we don't know, and figuring those out because we're super smart. Things that we should remember from the past. Okay, supplementary angles are two angles that form, I'm sure you've already beat me to it, 180 degrees. So like angle 1 and angle 2 together, 180 degrees. Vertical angles, two angles that share a vertex. So there's four versions of this in this. I'm going to use the purple here. Angle 6 and angle 8 share a vertex. So angle 6 looks like this. Angle 8 looks like this. Really happy that I used the same color, so it's really hard to see. But they share a vertex, which makes them congruent. And the last one that we don't use very much in this unit is complementary. So complementary, we're talking about two angles that when connected form 90 degrees. Vocab that we could use, but not necessarily a thing that we're going to be assessing on or working with specifically, because a lot of the work we do is going to be between parallel lines and a transversal. Let's build on what we did in the last lesson and find some missing angle measures in our system that we have here, our parallel lines and our transversal. So our first question is given, and given means like this. This is like this is true. Like we're going to tell you this is part of it. This is true about this. The measure of angle 2 is 98 degrees. So I'm just going to put a 98 degrees there for my sake. We're going to use it 2 more times, so don't overdo it with the writing on it. 98 degrees. What is the measure of angle 8? Okay, so I've got angle 2 here. I've got angle 8 there. Let's figure out if there's a relationship. Are they corresponding angles? Are they in the same position in relation to the lines in the transversal? They are not. Are they on the inside? They are not. Are they on the outside? Yes. So now we've got one question that's yes. They are exterior angles. But let's just make sure. Are they on opposite sides of the transversal? They are. So what we've proved there, and this is a geometric thing, is kind of proving things with the facts. What we've proved is that the measure of angle 2 is congruent to the measure of angle 8, which means, and I don't really like that. I'm going to write therefore, but I'm going to write therefore in geometric language, and therefore is written with 3 dots. Therefore, if the measure of angle 2 is 98 degrees, the measure of angle 8 is 98 degrees. Okay? Not complicated. You're just using logic. If you like to argue, you're going to love this. You're taking the pieces that are the facts, and you're assembling those facts in order and then proving your case at the end. Let's look at the next one here. I've got given that the measure of angle 4 is 98 degrees. So let's erase this so we can see what we're working with. Here is angle 4. It is 98 degrees. What is the measure of angle 6? That one. Let's figure out do they have a relationship. All right, first thing is, are they on the inside? They are. Okay. Are they opposite the transversal? They are. They're opposite the transversal. Which means, because they're alternate interior angles, so I'm going to actually write it this time. Alt interior angles. Once we know that they're alternate interior angles, those angles are congruent. The measure of angle 4 is congruent to the measure of angle 6. Therefore, dot, dot, dot. The measure of angle 4 equals 98 degrees. The measure of angle 6 equals 98 degrees. That's our answer? That's our answer. Given that the measure of angle, third one. Given that the measure of angle 1 is 82 degrees, what is the measure of angle 5? All right, the measure of angle, oh boy, okay, where's 1? Here's 1, all right, 1, 82 degrees. And now I'm looking for 5. Here's 5. Question mark. Okay. Are they both on the interior? No. Are they both on the exterior? No. Are they both in the same spot in relation to the transversal and the parallel? Yes. Which makes them what kind of angles? Do you remember? We just did this yesterday. Corresponding angles, which means the measure of angle 1 equals 82 degrees, and the measure of angle 1 is equal to the measure of angle 5, right? We're proving a case here. And then, therefore, the measure of angle 1 equals 82 degrees, and the measure of angle 5 must equal 82 degrees by geometric law. And that's how we find angle measures with just this. Let's look at a real problem and see what that looks like. Here's a real world problem. I don't even like saying that. Here's a real world situation that we're looking at here, and we've got a bookcase that somebody made, and here's a transversal that cuts through two parallel lines, and we've got a furniture designer who built the bookcase shown. Line A, here's line A right here. You can mark it as cursive A. Is parallel to line B. Here's cursive B. Ugh. Okay, don't do that. And we know that the measure of angle 2 is 105 degrees. So the measure of angle 2 equals 105 degrees. Find the measure of angle 3. Here's angle 3 here. And then justify your answer. So we need a reason here. Okay. Are they both on the interior? Yes. Are they both opposite the transversal? No. Are they both on the exterior? Of course not, because they were both on the interior. Are they corresponding? Are they in the same place in relation to the transversal and the lines? No. All right, so I think we've got two steps here we've got to work on. What's the first step? We've got to find an angle that's going to be congruent to angle 3. There's two options here. When we think back to our terms, alternate interior angles would mean that the measure of angle 3 and the measure of angle 6 are congruent. We also know that the measure of, let me get blue here, the measure of angle 3 is congruent to the measure of angle 1. So either way, if we can figure out what 1 is, we know what 3 is. If we can figure out what 6 is, we know what 3 is. Let's do 6 here just because. I don't know why. When I look at 2 and 6, I have an angle that goes to here and an angle that goes to here. They have a relationship. They're both connected to that straight line, which means that the measure of angle 2 plus the measure of angle 6 must be 180 degrees because they are supplemental angles. Now, we were given data, hence the word given, or if. I didn't say given. I know that angle 2 is 105 degrees. So I can replace this with 105 plus the measure of angle 6 equals 180. And then when I do that math, if I subtract 105 here, I get the measure of angle 6 equals 75 degrees. That's great. Therefore, this is the part that we put it together. Therefore, measure of angle 6 equals 75 degrees. Angle 6 and angle 3 are alt interior angles, which means that the measure of angle 6 and the measure of angle 3 are congruent. They are congruent. Now, because that's true, if angle 6 is 75, the measure of angle 3, the measure of angle 3 here is also 75 degrees. 75 degrees. So it took us two steps. We had to use a supplemental relationship and then our alternate interior relationship to get that. Or what we could have done is use our other supplemental relationship, and then angle 1 and angle 3 would have a corresponding relationship. Okay, good luck.